In this video, I'm going to show you how to find values for x given probabilities in a normal curve. So if we come here to Stat, Calculator, Normal, we'll see our normal calculator. And what we'd like to do is we'd like to set up a distribution of interest. So I'm going to set up a distribution corresponding to the heights of women. So the heights of women have a normal distribution. The mean is about 64 inches, and the standard deviation is about 3 inches. And so let's take a look at that distribution. So right now what's showing is the probability of an x value less than or equal to 64. Now 64 is the mean, which is about in the middle, and so we would expect and see that 50% of women are shorter than 64 inches. Suppose we were interested in the shortest 5% of women. We know that they would be over here in the left tail of the curve, but the question is, what's the height that would correspond with a cutoff between the shortest 5% of women and the taller 95% of women? So to find that, I would just come here to this box which gives us the area. Now remember, the area corresponds with the probability. So the probability or area of interest is 5%. And now if I click compute, I can see right here this is 5% of women, and the height would be about 59 inches. So the shortest 5% of women have heights of about 59 inches or less. What if we were interested in the tallest 5% of women? We know they would be over here on the right tail of the curve. How would we find that area? Well, you might think that all we have to do is change this less than sign to a greater than sign. But what that does is it gives us 95%. And we don't want 95%, we want 5%. So again, we put the percentage or the probability of interest in this box here, and then press compute. And so now we can see the tallest 5% of women would have a height greater than or equal to about 68.9 or roughly 69 inches. So to find a value of x given a probability, what we do is we put our probability in this answer box here, press compute. It'll shade the area that it's found, and it will tell us the value of x that we're interested in.